Hi everyone, we're going to locate the absolute extremum of the function on the closed interval. The first thing I want to do is to see if there's any critical numbers, and I'm going to take the first derivative after I rewrite this. This would be 6 minus 2x. So the first derivative is negative 2, and since there's no variables there, that means there's no critical numbers. When we get further into these, the harder ones, we will have critical numbers. Now, what we have here is this closed interval, negative 1 comma 2. So for the left endpoint, I'm just going to write end, I'm going to evaluate f of negative 1. And when you plug in negative 1, you're going to get 2 times, let's see, where are we? Or I can just plug it in this one. I'll plug it into this one instead. So it's a little easier. So that's going to be 6 plus 2, which equals 8. So the left endpoint is going to be negative 1 comma 8. And for the right endpoint, we're going to evaluate f of 2, and that's going to be 6 minus 4, which equals 2. So we have 2 comma 2. Now, this is going to be the maximum, and this one's going to be the minimum, because my 8 is bigger than my 2. And you're looking at the y part. Okay? So the next one is very similar. I'm going to go ahead and rewrite my function as 2x over 3 plus 5 over 3. When I take the derivative, I'm checking for the critical numbers, which is 2/3. And that means we can't plug anything in, so there's no critical numbers. Remember, on the critical numbers, you're setting your derivative to 0, and that doesn't make sense, so there's no critical numbers. Let's do it that way. And now we got to evaluate the left endpoint. So that's going to be f of 0, and our right endpoint would be f of 5. So when I plug in 0, I get 0 plus 5 over 3. So at 0, my y is going to be 5/3. And when I plug in 5, I'm going to get 2 times 5 plus 5 over 3, which is 15 over 3, which is 5. So at 5, we're at 5. In this case, this number is smaller than this number. So this is your minimum, and this would be your maximum at the endpoints. Okay, that's all. Thank you. Have a nice day. Bye-bye.